All right, welcome to The Explainer. Today, we're going to dive into a really fascinating mystery from the history of science. It's a secret that's been hiding in plain sight in pretty much every physics and engineering class. It's a story that involves a lucky guess, a totally shocking discovery, and, get this, a choice that affects literally every single circuit diagram you've ever seen. So let's just jump right into the big question. Have you ever been in a class where you're told that electric current flows from positive to negative? And then, maybe in a physics class, they tell you that electrons, the things that are actually moving, go the other way, from negative to positive. It feels like a massive contradiction, right? So what gives? Is physics totally broken? Well, no, but there is an amazing story here. So to get to the bottom of this, we can't just look at a modern textbook. Nope. We have to jump in a time machine and go way back to a time when electricity was this strange, new, and frankly, kind of frightening force that scientists were only just beginning to understand. Okay, so this whole thing plays out over like 200 years. It starts as a total mystery. Then there's an educated guess, which somehow becomes a global standard. But then, boom, a huge discovery throws a wrench in the works. And that leads to the weird compromise we all live with today. All right, first stop on our journey, the 1700s. And our main character here is none other than the brilliant Benjamin Franklin. He was one of the first people to really try and figure out what electricity even was. So Franklin came up with this really elegant idea. It was pretty simple, but honestly powerful. He imagined electricity as this invisible fluid. And he said, look, if an object has too much of this fluid, we'll call that positive. And if it doesn't have enough, we'll call that negative. Super straightforward, and it was a huge step forward in how we thought about charge. Okay, but this created a big problem. A huge question. Which way does this fluid actually flow? Does it go from the plus, where there's too much, to the minus, where there isn't enough? Or the other way around? The thing is, he had absolutely no way of knowing for sure. He literally had to guess. It was a coin flip, a total 50-50 shot, and he put his money on it flowing from positive to negative. And that right there is the most important word, convention. This wasn't a scientific proof. There was no experiment, it was just an agreement, a starting point so everyone could be on the same page. And yet this one little guess would become the bedrock for the next 100 years of electrical science. So how on earth did a random guess become this unbreakable rule for every scientist and engineer? Well, it all came down to a brand new invention that changed everything. Okay, so in 1800, this guy, Alessandro Volta, invents the very first battery. And this was a game changer. All of a sudden, electricity wasn't just a static shock or a lightning bolt. It was a steady, continuous flow. You could actually use it. So people start building circuits to do useful stuff. But to do that, you need a blueprint, right? A standard way to draw things. And what do they use? You guessed it. They all just adopted Franklin's convention. Current flows from the positive side to the negative. And for nearly 100 years, that was that. Case closed. The entire field of electrical engineering, every equation, every textbook, every single diagram was built on that original 50-50 guess. And you know what? It worked. It worked perfectly. Nobody had any reason at all to doubt it. Until the big plot twist finally arrives. This is the moment when a new discovery comes along and threatens to pull the rug out from under a century of science. So, the year is 1897. Science is absolutely buzzing, on the edge of a revolution. And a British physicist is about to find a particle that will completely flip our understanding of electricity on its head. That physicist's name was J.J. Thomson. And while he was messing around with cathode rays, he discovered the electron. And this discovery created a massive problem. See, Thomson proved that the little bits that are actually zipping through a wire are incredibly tiny. And they have a negative charge. But wait a minute. The whole convention for 100 years was based on the idea that a positive charge was moving. So if these moving particles are negative, well, opposites attract, right? They would have to be flowing away from the negative terminal and be pulled towards the positive one. The actual physical reality was the complete, total opposite of the convention everyone had been using for a century. You can imagine the panic, right? This put the entire scientific world in a really tough spot. A full century of work, all the books, all the diagrams, all the math, was built on an idea that was technically backwards. So what do? Do you go back and change everything? Think of the chaos that would cause. Well, what they came up with was pragmatic. It's a little confusing, maybe, but it was a practical solution. Instead of trying to rewrite all of history, they basically decided to let both ideas live side by side. So you might be asking, why on earth would they keep the old wrong way? Well, for one, it was just too deeply baked into everything. It was already printed in every textbook, on every schematic. Every engineer had learned it that way. To change it all would have been an absolute nightmare. But here's the real kicker. The math still worked. It worked perfectly. Turns out a positive charge moving one direction is mathematically the exact same thing as a negative charge moving in the opposite direction. For the purposes of a circuit, the end result is identical. It just works. And that brings us to the system we still use right now. We have two models that we talk about. First, there's conventional current. That's the old school historical model. It imagines a flow of hypothetical positive charge moving from positive to negative. This is what you'll see in most circuit diagrams. It's the language of engineers. And then there's electron flow. This is what's actually happening, the real physical movement of negative electrons from the negative terminal to the positive. This is what physicists and chemists are usually talking about. So, at the end of the day, it's not that our model for electricity is wrong. It's more that we have this historical model that we keep around as a tool, because honestly, it's super practical and it just works for designing circuits. It's a really cool story about how science isn't always a straight line. It builds on its own history, warts and all, even on a lucky 50-50 guess. And that really leaves us with a pretty fascinating thought, doesn't it? This whole story is such a great reminder that sometimes the things we take for granted as fundamental rules are, well, they're just really useful conventions that everyone agreed to. And it kind of makes you wonder, right? What other truths out there in science are just like this? What other things that we think of as fundamental laws are maybe just the most useful story that we've all agreed to tell for now?